what's the construction of the robot going to look like? So let's talk about just a quick intro. My name is Mike Corsetto. I'm the head coach of Citrus Circuits, Team 1678. Professionally, I'm the co-founder of an engineering consulting company called Davis Mechatronics. I have been doing FRC as a student 04 to 07, and then I've been coaching Citrus since 2008. So do the math. I think it's like 17 years or something like that. And a lot of the lessons you're going to hear in this presentation are really practical things that we pulled out of many years of trial and error on Citrus Circuits, and our process has evolved over the years. So what are we going to talk about today? Well, we're talking about a lot of different ways to answer the how question of how are we going to tackle a certain task in this year's game. So first we'll talk about what this step is about, why this step in the brainstorming process is important, and then we'll talk a lot about the different ways that you can approach this question. So yeah, there's some desks up front, there's some desks up here as well if you need them. We'll talk about hand sketching, some keys to successful hand sketching in FIRST Robotics. We'll talk about whiteboard discussions, Crayola CAD, other ways to mock up the game with mock gameplay. We'll talk about effective approaches to prototyping, an alpha robot principle, which is something we've implemented over the last 4 or 5 years, and then talk about where you can get external inspiration as well for how you approach the design of your robot. Okay, so let's talk about what this step is about. On Citrus, we've been doing kickoff a certain way for the last, I think, 12-ish years. And actually, I've been talking about the way we approach kickoff for the last 12 years. And the old way we've been doing it is in 3 very distinct steps where we read the rules, everyone reads the rules, and then we answer the what questions, which was a lot of Austin's presentation. What's our strategy? What will the robot do? Basically setting the scope for exactly what the robot is expected to do by the end of the season, and then answering the how questions afterwards. So what are the ideas for how we would accomplish all the different things we set out for the robot to do in our scope document? The issue that I've had with this is when we do the what's discussion, it usually takes about 24 hours. So, well, 24-hour in absolute terms, it's about 8 hours of meeting time, where we start talking about the what questions at the second half of the first day. So, you get the kickoff, you get the new game, you read the rules, you pass the rules test, and then the whole team starts discussing, well, what should the robot do? And obviously there's a lot of thoughts, we have processes, there's a lot of opinions on what the robot should do, and it starts to settle out into, okay, it's pretty clear that we need to be able to score in L2, for example. No one's arguing that the robot this year shouldn't be able to score in L2, but there's some stuff that's less obvious, like, do we need to score in the net? This year was interesting because it's like, well, the net's worth 4, but the processors were 6, but then their human player can throw the ball into the net, and then it's only an additional 2 points for the Alliance. So which one's better? Obviously, if you score in the net, you got to be able to reach up super high, but maybe it's really hard for the human to score from the processor into the net, and so maybe the processor is actually where we want to score. These are things that are less obvious of an answer for our team to figure out of what we should do versus what we shouldn't do. And so at the end of the first day, basically 4 hours of discussion, we get whiteboards that look a lot like this, where there's some things that we've said we clearly need to be able to do. There's some things we've said we clearly don't need to be able to do, like intaking upright coral from the ground. We figured most of the coral is going to be knocked over on its side. We don't need to worry about directly picking up coral that's upright, even though some of them started out that way. So we get to this point where there's some obvious things in our scope, and then there's some more contentious topics, right? What ends up happening on the second day is we end up going back through and spending another half day talking through these contentious objects or subjects and trying to develop consensus around them. Unfortunately, on Citrus, what's ended up happening is a lot of it just comes down to people saying, like, trust me, bro, we need to be able to do this, or we don't need to be able to do this, right? And for me, it's been a really frustrating experience over the last decade, because I really want to have more tangible insights that can justify whether or not we add something to our scope. And I know we're not talking about that much in this presentation, but if you really want to TLDR it, the more scope you have on the robot, the worse your robot's going to be at any of the given things that you do. That's just a universal truth. It's true for us, it's true for every team in this competition. The more stuff you take on, the worse your robot's going to be at all of the different things you choose to do. So deciding what scope you take on is actually mission critical to having a successful season. And if you waste your team's resources on stuff that does not matter to the scope of your robot, you will have a less competitive season. So this process of determining the what's is really important, but on Citrus, we've been doing this in a vacuum. So what are we changing? We're having a new start to the season this year. So I'm giving you a preview. I haven't even talked to Citrus about, well, I've talked to our leadership. Our leadership has helped develop this, but the rest of the team doesn't know about this yet. So you're getting an early preview on what's going on. This year, we're going to develop a list of what's questions at the end of day one. Meaning we're gonna have 3 to 5 contentious topics, like should we pick up cones off the ground in 2023? That was a really contentious topic. Some good teams did it, some good teams skipped it. What was the right answer, right? There's a whole blend of possibilities there, right? Same with, anyway, you could imagine a number of different things that could be in scope or could be out of scope, and trying to figure out what's what is pretty difficult. So we're gonna develop that list of what's questions, the things that we don't know yet, and we're gonna also try to figure out, we're gonna propose how we might get to an answer on those questions. The answers, and we'll talk about all those methods are what we're gonna talk about. So days 3 through 14, we're gonna be doing all the things that we're gonna talk about in this presentation. And on day 8 of build season, so the following Saturday, we're gonna huddle back together as an entire team, and we're gonna talk about the contentious topics of the what's that we haven't decided on yet. And we're gonna use all the data from all the things we're about to talk about, and we're gonna merge it all together. People are gonna present on the various insights that we've developed as a team, and then we're gonna decide the final bits of scope that we haven't settled on yet. And so the purpose of this is to avoid this trust me bro sort of mentality of like, no, trust me, this is gonna be really important, it's not that hard, blah, 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 and we're just kind of guessing on day 2. We're done doing that, all right? We're gonna move into a data-backed methodology for finalizing the scope of the robot. Some of the stuff is easy to finalize, some of the questions are harder, and we're gonna give ourselves 6 more days to answer some of those questions. Are you still there? Yes, I am still here. Stay in the call. Excellent. Okay. Oh, and I should emphasize too, if you have a question, write it down. I will try to get through this material as quickly as I can so I can answer all your questions at the end of the talk. Cool. All right, so now we're going to talk about all the different ways that you can determine the how part of the equation. How should this robot be built in order to complete the scope that we are aiming to complete? So first tool at our disposal is sketching. Okay. Has anyone here hand sketched something before? Yeah? Okay, cool. A lot of people. Great. Hand sketching is a really valuable skill, especially in the context of trying to communicate ideas to other team members quickly. We do hand sketching every year as a part of our kickoff weekend process, and we're not changing that. It's going to be a part of our process this year as well. The things you need, obviously you need graph paper, you need pencils. Rulers are great to have so your lines are actually straight. A USB document reader and projector are tools that we use on Citrus to project the sketches to the entire team so that when our groups are, during our brainstorming weekend, are presenting their ideas, they can share those ideas with the whole team. And then the most important element of hand sketching that I think is overlooked and something that we do on Citrus is an agreed upon scale. Okay, so when we hand out 8.5 by 11 sheets of paper, we also specify, for example, one cell is 3 inches, or 4 squares is a foot, something like that, and you set an agreed upon scale. The reason we did this is because this is a sketch from 2014. I don't have an image of real robots to compare it to. Anyone familiar with the 2014 game? Okay, yeah, we got some veterans that know what's up. So the 2014 game, you were launching these giant track balls into goals, right? And these were like big, exercise balls essentially, right? Probably about 30-ish inches in diameter. And in 2014, we got to the sketching portion where all the different groups were sketching out their ideas for a robot. And we got a lot of sketches that look like this. It's a little hard to see in the image, but this is a 2-foot diameter yoga ball within a robot. And if you're not familiar with the game, I'm not going to fault you for it, but I guarantee you that most robots did not have 18-inch wheels, and most robots were not 8 feet long. Okay, that was a little bit outside of the size constraints from that year's game. So we were running into this problem where students were trying to communicate their ideas, but without an agreed upon scale, they were giving us essentially garbage like this. Because nothing in this sketch is actionable, because the sketch that they've done does not incorporate the reality of the rules of the game and the size of the game elements. So as a team, sketching is a really valuable step. I encourage every team to do this in their brainstorming weekend, but you need to agree upon a scale, and then the best tool that you can do is find a washer size in your shop that once you agree on a scale, let's say we had like the balls from this year, right? The algae, right? So the algae was, I don't know, like 60 inches, right? Yeah, 6, okay, cool. Yeah, we got the exact rule there, that's awesome. So you take that size, you take your agreed upon scale, and then you find a washer that's almost the correct size based off your scale, and you put a couple of washers on each table's discussion group. And so when people are sketching their ideas, they can trace the exact washer that they need to use to communicate the scale. It sounds like a simple thing, but I guarantee you half of your sketches will look like this if you do not agree upon a scale and give people the tools to be successful in their sketching efforts over the weekend. So good lesson learned from that process. And then we talked about sharing sketches. One other tweak that we do on Citrus when we share our sketches with other team members, because again, there's a lot of great ideas are flowing. Another problem that we see is sometimes one person will get really into the idea that they've been cooking up in their head, right? They're like, oh my gosh, I got the idea that's gonna win us Einstein. I'm gonna sketch it out, but they're doing it all in a vacuum. And then they get up to present, and they're presenting for the first time to the rest of the team, and they don't generally do that great of a job communicating the idea. So another kind of guideline that we have on Citrus is when groups are presenting the ideas that they've sketched out in their smaller table groups, the person that did the pencil drawing is not the person that speaks during that group's discussion. Does that kind of make sense? So another person is describing the sketch that one of their other group members might have been putting pencil to paper on. And what this does, this adds another layer of preparation to make the presentation process a little more effective and smooth. Again, we're talking about how we answer the how question. These are all about communicating ideas effectively, right? And trying to get to an optimum truth. So so that's a tool that we've been using. And then also just a tip, using a marker or something like that or a pen to make things a little bit more contrast and visible. Sometimes the document readers get a little washed out, although they're getting better every year. Okay, great. Whiteboard discussion. So second tool that we use a lot on Citrus is the whiteboard. The first and probably the most effective use of the whiteboard on Citrus is we have a whole wall of whiteboards, probably like 36 feet wide of whiteboards in our main discussion room that we do kickoff in, and they're getting full of ideas as groups are presenting. And whiteboards are a great dynamic tool where you can write down all the different ideas and start noting them up. We also note little hash marks as ideas come up multiple times. So as different groups are presenting their sketches, someone's off in the corner writing all the different ideas down in kind of bullet point summaries and hash marking as themes and stuff come up multiple times. So you can start to get an idea of what some of the trends might be of the different ideas that are developing within your team. But having a whiteboard to write down, note, and then down select later on during your discussion phase is an important part of our how process. The other thing that I love whiteboards for overall, this is not just on kickoff weekend, this is all season long, is just sketching up random 2D garbage all the time to communicate ideas. Sometimes, using your hands and pointing is not enough to effectively communicate an idea quickly. And so on Citrus, you'll find whiteboards all throughout our facility because whiteboards are a really important tool for us to communicate with each other in a fast-paced environment about the ideas that are developing. So these 2D sketches on a whiteboard, we have a lot of large whiteboards. It's also a lot of work to keep markers available. Oh, geez. And then pro tip, in a pinch, you can use shower board from Home Depot as cheap whiteboard material, but you have to clean it a lot. It doesn't really clean off as well as official whiteboards. So Citrus, before we had some official whiteboards, the shower boards were all over the place. Okay. Cool, we're cooking through here. Crayola CAD is the third tool that we use to help answer the how's questions, all right? So, what is Crayola CAD for? Crayola CAD is a quick way to see how a system might look in 3D space and help validate your concepts. This is an example of a Crayola CAD that we had this year, and then this is my scribbling around how we might add a human player loading to it, which never, a lot of this stuff didn't end up happening, but you can kind of see how it might look like the Citrus robot a little bit. I'll talk about this in a second, but to make Crayola CAD effective, you kind of need to understand, generally speaking, how FRC type robots are normally built. A lot of FRC mechanisms can be boiled down to 6 to 8 building blocks that are tweaked in different ways, different dimensions, different widths, lengths, stuff like that. But a lot of them are kind of turn the crank year over year, right? And it's just about figuring out how much compression do we do, how many launcher wheels are there, how many intake rollers are there, where are they relative to the bumper. Like, these are some of the elements that tend to be optimized year over year, but the core building blocks are fairly thematic year over year. And so the Crayola CAD principle allows you to tweak a couple of key dimensions and make things that look robot-ish really, really quickly without having to use, you know, the tube generator and put bearings and shafts and wheels, all these things that take a lot of time to get to something that's in 3D space. This gets you to 3D space a lot faster, but it does require some familiarity with what FRC robots generally look like. The other cool thing about Crayola CAD is you can build up this is a 2D image, but this, trust me, this is a 3D thing, right? You can put things like this right into the field CAD, and you can see in 3D space how a potential robot shape interacts with the field around it. So, like, what does the reach look like into L1? Or, you know, what would this look like when it's in net scoring position? How tall does it look? Like, does it have good reach over the net? These are things that you can do in a manually made 2D sketch, but a lot of times it's more vivid and visual in the 3D full field environment. And so the Crayola CAD process can be really helpful from that regard to helping narrow down how exactly should we build this robot, how many stages of the elevator do we need. I know that was a big topic of conversation this year, right? So a lot of things you're able to flesh out with a little bit more detail in Crayola CAD. So more info on doing Crayola CAD. Technically, what you saw is a variety of Crayola CAD called Crayon CAD. It is who here is familiar using MKCAD and Onshape? Anyone familiar using MKCAD? Okay, cool, I see a number of hands. If you go into MKCAD, there is a Crayon CAD section of MKCAD. I highly, highly encourage that if you haven't been familiar with using that tool, you open it up and give it a shot over the next couple of months before we get to build season. Because once you understand the building blocks of how Crayon CAD is set up, it can be a really powerful tool to building up mock robots really quickly and looking at them in the 3D environment. They have fully baked systems. This screenshot is, so there's an frcdesign.org resource that talks about how to use Crayon CAD. So you can just go to frcdesign.org, just Google FRC Design, Crayon CAD, and you'll find the web page, the landing page, where they talk some about how to use the tool. But you can see in this image, like there's a pre-built swerve generator, and you can choose whatever module you want to have as a mock-up, and then you can choose like how high to make the bumpers, how big to make the base, all that sort of stuff. And then you can add an intake to that, which is just a simple slap-down intake where you literally just like put in 3 variables, and it generates this mock-up slap-down intake, and then you can put a launcher hood on it and a ball tunnel, and you can add these different elements to it and build up a robot just so you can see how all of these systems are going to fit together and possibly meet the requirements you have set in your what section. So definitely encourage going to frcdesign.org. Check out Crayon CAD. It's a super useful tool. We use it a lot on Citrus to help validate, and we've been using Crayon CAD since like 2021. I mean, it's been great for us, or Crayon CAD-like tools. Okay, another thing that is going to be helpful in determining your hows is mocking up the game and understanding some of the sensitivities about the game beyond just discussions in front of a whiteboard or with the rules in front of you. So a couple of ways that you can do fun mock-ups in the physical world that can help gain more insights into how the game's going to play out is chairs in a room. This is a picture of us playing Chairs in a Room with 118. This was actually at Champ, so this was after the brainstorming process, obviously. This was more of just as a fun bonding exercise. But the concept with Chairs in a Room is you just need a room, and you need 6 chairs, and you need at least like 15 people for this exercise to go relatively well. All right? And you can use whatever you have at your disposal, desks, chairs, to mark out the rough field. And then you can have 6 robots in chairs, and you could have 6 drivers pushing the chairs. And then you set a couple other roles. Questions at the end. That's okay. Awesome.
Safety, use a furniture dolly, not a chair.
Oh, okay, great. Yeah, furniture dolly. Sweet. Anyway, so assign scorekeepers, timekeeper, a videographer, set up some rules, and then you just go for it and try a few matches and get an idea of where are people scoring, what are the final scores looking like. It's just one more data point that you can use at your disposal. Another cool data point is fake cycles with the robot. So how many teams generally have one robot, either a drivetrain or a whole robot that's driving right now? How many of you guys have a robot that moves? Oh, most teams. If you're at Capital City Classic, I hope you got one, right? Generally, we do as well, right? And if you're diligent about it, you can make sure that robot continues to be running at least through the first week of this upcoming build season. I know a lot of teams have to take parts from one robot for the next, but try your best to keep that robot running for the first week. And then what you can do is do something like, not everyone has, this amount of space, but set up whatever space you have available and mark out some of the major field elements. And then you can actually use the robot with your driver to kind of fake cycle with your robot. So you can tape out some of the key waypoints. You can assign a driver, a timekeeper, a scorekeeper, videographer, and drive the robot between those cycle points, and then note like how many cycles were we able to get done? What were the issues? What were our assumptions, right? Based off how many cycles we just did, what would the score be? And so these sorts of things give you an indication of what a typical robot or what your robot might be able to accomplish if you meet some of your goals for this season. So it's just another way to start to answer the how question. And like in 2024, if you did this, you probably would have found out that 85% of our time is just driving from one end of the field all the way to the other. And there's not a big difference between, driving to the corner of the stage and driving right up against a fender. And that's why a lot of really successful teams, I think of A41 that year, had a lot of really good success driving all the way to the fender to shoot, because once you're driving 45 feet already, another 5 feet at full velocity is not that much different so it was not much of a difference to go all the way to the other end versus stop just short of the other end to make a shot, and the shot was way easier going all the way. That's an insight that you could get just out of fake cycles, and then you can wrap that right back into your brainstorming process and say, you know what, based off of our fake cycles, we found that it basically didn't matter if we stopped 5 feet before the fender or went all the way up into the fender. Actually going into the fender was faster because we just slammed into the wall versus stopping and trying to line up. And so we're going to actually assume that it's a-okay to skip shooting long and just do that one fender shot. These are the kind of insights that you can get actually driving a robot around and understanding it. You can also understand, for us all as well, I don't think I noted that in the slides, but doing fake cycles gives you a really good idea of what the ceiling could be in autonomous. So you have 15 seconds, and it's like you plot out what a robot might be able to do in those 15 seconds, and you can kind of make assumptions, just guessing, but it's way more powerful to see it happening IRL on the carpet. Okay. Cool. Let's talk about prototyping. One of the key things with answering the how questions. Okay, some keys for effective prototyping. Set your teams and your systems before the season starts. Okay, so a lot of elements of prototyping are the same year over year. The classic one is a roller intake to intake whatever the game piece is, all right? And we are just as guilty of this, but a lot of times we don't have our pieces in place to be ready to build a intake for any particular game. The thing that we have done successfully for the last number of years is we set out groups for prototyping before the season even starts. Now, we don't know what those groups are going to work on, but we do make an effort to set out groups that we know have a good balance of skill sets, so that when the team assigns them a task for prototyping, like, hey, we really want you to try this version of a climber, we know that they're going to have a fairly competent designer, they're going to have some fabricators, they're going to have an electrical person, they're going to have a software person, they're going to have a group of students that are able to effectively work together to execute on that prototype. But the other important part of this is how to use quick methods to come up with insights without having to reinvent everything from scratch. And so there's a number of teams. I put some slides or some pictures from 5026 in SF. They have a really cool system. I forget what they call it, but it's a series of 3D printed objects that clamp or bolt into 1x1 tubing, and basically with a series of junctions and motor adapters and a couple other bits and bobs, you can do fairly complex geometry really quickly. And you can imagine this is an algae intake, for example, and if you don't like the compression on the ball, you can either pop off the shaft and swap the wheels out, or you can adjust the clamps and slide the whole shaft up or down a half inch or an inch or whatever, right? And this is a lot more time effective than something I see a lot of teams doing, which is they will design an intake in CAD, and then they'll maybe take it on the router or the laser cutter, and it'll have just the bearing holes they need. And then they find out that they're squeezing the ball too tight or not enough, and then they gotta go back into CAD, adjust a number, cut another version of it, tear their whole prototype apart, build another prototype up, and then run it again, right? That is a very slow workflow, and it's not gonna get you to the answer you want, which is, can we pick up a ball with a roller like this? Do we need 2 rollers? Do we need smaller wheels or bigger wheels? What's working better? These sorts of tools get you to those answers faster, and that's the key with prototyping to be effective, is having the answers quicker. So having a system in place before the season, for example, I don't know what Citrus is going to do yet. We haven't really figured out what we want our standard prototyping system to be this year. But if we decide to use something like what 5026 has, I guarantee you our 3D printers are going to be buzzing like crazy in November and December to make as many of these as possible and have fully built systems ready to go so we can run those things come kickoff. Okay, and then selecting what to prototype. This is also an important use of resources. So not everything needs to be prototyped, all right? There's a lot of things, like I talked about before, there's a lot of elements of robots that are basically the same year over year. Things like elevators, things like pivoting arms, things like that. These are not things that you get a lot of value out of prototyping, right? The things that you get value out of prototyping are usually specific to that year's game and interactions with either the game piece, so things like intakes to intake a ball or another type of game element, or things like launchers that are going to launch the ball into a goal and figuring out what dimensions make sense for a launcher, or things like indexers. How do you store and hold a game piece within the robot? These game piece interactions are actually valuable to prototype because your assumptions may not bear out in reality. Like in 2020 with the foam power cell balls, those things were like New York subway rats. I mean, they squeezed through every little crevice, right? They did not behave like a normal rigid ball. Like they behave more like a ball that sometimes doubled as a pancake, right? And so having prototypes that were real, dealing with the dynamics of the ball, are really important to actually building an effective robot. If you just assume the ball was a ball and the ball's gonna stay ball-ish shape the entire time, you were in for a bad time if you built your robot based off that assumption. So important things there. And then field interactions as well. I think climbers come to mind here. So, interacting with field elements that are rigid or semi-rigid, or in this year's game, swinging, right? These are all difficult things to really fully mentally capture, and sometimes there's no way to get around the right answer besides building prototypes and testing them with the field elements. So you want to think about the areas of the robot that have yet to be validated because there's no corollaries in the past, or it's not a system that's usually built year over year, and that's what you want to focus your prototyping efforts on. Okay, consider multiple options as well. This is easier said than done, but another trap that I see teams get into is the engineering, kind of like phrase is marry your first idea, right? This idea that the first thing that I came up with is probably the best idea the world's ever seen, and we're just gonna go full bore into that, okay? Generally not an effective way to get to the right answer. Also not effective to prototype a bajillion things because you just don't have, you do not have infinite resources. But I think the middle ground here is sometimes it is helpful to have two prototypes of different approaches to the same problem running in parallel. And then the other element of this is you want to, as a team, set a culture where when we don't use an idea, that's not attacking the people that made the idea, right? And so this is where phraseology around like not, oh, that's Susan's prototype and that's Nathan's prototype. Those are not effective ways to collaborate as a team, all right? You want to say that's the under grabber climber prototype and that's the overclog prototype, right? You want to distance the people from the prototype and make objective decisions based off the results and try to remove the stigma of people feeling attacked when their ideas or the things that they've contributed meaningful time and energy into don't get moved forward with. This is a fun picture of two of our main designers in 2022 throwing a climber out that did not work. We totally pivoted to a different climber and we tried to make it fun and stage this picture of them throwing the entire mechanism that they spent the last 2 weeks working on into the trash can, right? And this is actually not the first trash can picture we've taken on Citrus. There are multiple. Actually, I got another one coming a little bit later on. But again, it's this idea that we have to have a healthy amount of self-skepticism and understand that what we think about initially is likely not the best thing. You just have to assume that, right? Because none of us are perfect. We have to assume that the stuff that we think of and the stuff that we build has flaws, probably many flaws, and we need to test those out. So that takes me to my next point, which is when you build a prototype, you want to stress test it, not best test it, okay? What I mean by that is you need to push your prototype to the limit and find all of the weaknesses related to the prototype. The classic FRC prototype test that you will probably find 200 of on YouTube is maybe a bumper if they're good, right? A bumper and a shaft with a drill on it, and they press run on the drill, and they roll the ball in, and it goes up and over the bumper, and then everyone cheers, right? That is like the classic bad intake prototype test that I see hundreds of on YouTube, okay? What is that thing? One, does the robot just always sit on the ground and the balls roll to the robot right into the middle of the intake? No, right? So the intake should probably be moving. You should probably be shoving the balls in from the side. You should probably shove 2 or 3 in at the same time. How does the intake handle that stuff? You need to stress test, overload it, feed balls into the side, all these sort of things. Same thing with launchers. Like, you don't just build a launcher, put it on the ground, see a couple go in the goal, and you're like, all right, wrap it up, right? You want to test it close up, far away. How far can you go? If you put 100 in, how many are going to make it in, right? On Citrus, like in 2024, we threw prototypes before we had robots built, just prototypes, probably put like 3,000, 4,000 notes into the goal and documented that and figured out what our accuracy percentage was and watched as the accuracy percentage on each iteration of the prototypes went up and up and up until we hit what we felt like was probably an optimum at a given range, and then we hit go on the design for that build, right? But that requires again, it's more that healthy level of self-skepticism of like, this is not a perfect system, let's qualify how good it is, and let's try to make it better, and let's keep stress testing these elements of the system. And then I call them reps, but doing things multiple times over and documenting the level of accuracy or effectiveness or what breaks or jams, it's gonna help you figure out where your problems are. So having data on the reliability and videos of the failure modes are important elements to having an effective prototyping process. Here's just like a Slack media screenshot of a certain time period from this January when you can see a lot of pictures of like tape measures and intakes and videos of intakes running and videos of our alpha running. This is just like a snapshot in time of like 2 days of Citrus prototyping madness, all summarized in our Slack media channel. So anyway, all that to say, lots of testing of your prototypes, critical to developing good prototypes. Okay, let's talk about alpha robots for a second. This is a bit of a stretch goal, but I just want to be, fully transparent about our process on Citrus. And if there's any inspiration here, I think that's effective as well. Okay, so what is an alpha robot for? It's not for testing the end game, although you do see a climber on here. The climber never worked. It's not a side quest function tester for like other bits of the game that are not core elements of the game, like the spin wheel in 2020, right, with the really dumb color wheel. What it is for, it's for driving, it's for intaking game pieces, it's for maybe indexing them, and it's for scoring game pieces. That's what these things are supposed to do, right? It's able to teleop cycle at a basic level, and it's probably able to run autos. That's what alpha's for, all right? Here's a picture of our 22 alpha. We don't talk about the 23 alpha, that was terrible. Here's our 2024 alpha. How do you build an alpha quickly? Because it's a lot of work to build an alpha, right? I mean, it's like a whole nother freaking robot. Like, how do you do that, right? Well, there's a lot of hacks you can do to make this go a little bit better, okay? One, and this is something that we do on Citrus every year, is we'll take one of the, maybe a past year's robot or a past year's practice robot, pull all the stuff off the top of it, so it's just a drive base and bumpers, and say, yep, there's our alpha base for next year, right? And so we're ready to go with an alpha. It's pretty minimal work, so have your drive base and bumpers built. Have your CAD structure set up for that drive base. So, take the CAD for that year's, the whatever robot you're mutilating for your alpha, right? And strip all the stuff off the top of it in CAD and have the CAD as ready to go. So you're ready to start adding in the mechanisms you're gonna put on your alpha. The other thing that we did, and this is a good example on the next picture over. This was our 2025 alpha. It's actually using our 2024 clone of 2056. It's using their arm and just adding on another stint of an arm, like that made it an 18 inches longer. So we use the arm and the drive base from 2056 as our base for the 2025 alpha. And so maybe you have an old elevator from a past year's robot that you could keep on a drive base, because if next year's an elevator game, maybe you could have the elevator and the drive base already working, and then you just need to get an end effector on it, and now all of a sudden you're cooking, right? So the idea here is building quickly and having stuff in the library ready to go so you can start scoring within a couple of days past kickoff. And then you need to identify the couple of elements to the system you're gonna need to do this teleop cycling. And then you wanna possibly consider building some of your prototypes that we talked about earlier in the method where they could be strapped onto your alpha. So like the 2022, this alpha was a combination of an intake prototype and a shooter prototype. And then all we had to do was figure out like a little bit of like belting in the middle. And this is just like a couple pieces of plywood and some 1x1 to strap it all together. Like I said, the climber never worked. It was just there for show. But so what? And again, this drive base was built before the season started. I mean, all this stuff was it's all hack and slash. But you're trying to get to the point where you can cycle with something relatively quickly. That's what 2024 did. That's what 2025 did. Although this one also would chuck coral 15 feet in the air, but that's another story. Okay, so what do you do with your alpha? You get early insights into the gameplay. All right, you get to understand how the game might flow because you're scoring with the real robot. All right, you can learn about what's easy and what's hard about scoring. So for us, it was surprising. The intaking was actually fairly easy with this claw right on the ground or from the human player load, but it was really hard to get the auto score to be perfectly right to put onto the post, right? And so we learned through this alpha process auto score, which we had never done before. In 2023, we were all manual drive, right? So this is our first year using cameras to align to a game element to place a game piece. Very tough to do when you've never had experience doing it before. And so this alpha was critical for our software to gain experience with those auto aim, auto score functionalities. And then the other thing that we use alpha for is pushing the limits of what you can do in 15 seconds. I talked about using your drive base to do that as well, but the alpha just takes that one step further, and we can start to figure out what are the things we need to speed up to hit our aggressive autonomous goals. And then the other thing that we use the alpha for is our driver is doing weekly practice sessions, 2 or 3 weekly practice sessions with the alpha robot until the beta robot's ready to go, which is usually 3 weeks later or something like that, right? And so there's this idea of getting constant driver practice with whatever robot you have at your disposal, and building an alpha quickly gives your driver something to work with. Okay, last section, and then we'll have a couple minutes for questions. External design inspiration. This is probably my favorite part of the talk because we do have a golden rule of steal from the best, invent the rest. Taking external inspiration for your robot is one of the most efficient uses of your time, okay? Because there's a lot of people in FIRST that are graciously sharing a lot of their development process, and we'll talk about what some of those tools look like. But the flip side of this is there really is no honor in forcing an internal idea over a better external idea. We talked about the trash can earlier and throwing something in the trash, all right? A big reason we threw that in the trash was we saw a great climber posted by another team, and we were all collectively like, well, we could keep trying with this, or we could build that. And in 24 hours, we had built a copy of the other team that we saw on the internet, right? There really is, I think that the exciting thing about using other inspirations is there is something powerful about having the humility to recognize that other people might be further down the road than you, and you can learn from them, right? Some good examples of how Citrus did this in 2013, back when it was kind of hard to copy teams. We took 254's intake and 973's launcher and made a whole new robot over the course of 3 events. And this was our first year making it to Einstein. And then in 2024, we had a beta robot, which I'll talk about a little bit, that was absolutely terrible. And so we pivoted and full-on copied Spectrum's robot in 2024, and that was our last time on Einstein. So copying is a good thing. Another place to get inspiration from is past year's games. So a lot of these lessons are learned year over year, so you can get a lot of great mechanism ideas looking at previous year's examples. So 2007 to 2011 is a great example of like inflatable rings scored on posts. I mean, the robots were almost identical. You could basically put a 2007 robot on the field in 2011 and just start cooking, right? Best year for an alpha ever, by the way. Like I talked about the exercise balls in 2014. Our intakes in 2014 were a copy of another team's intake in 2008 because they were also using large exercise balls, right? So there's a lot of themes that are repeated year over year that you can use as inspiration into your house of how are we going to actually tackle this challenge. Okay, another place to look for inspiration is Robot in 3 Days. Robot in 3 Days is a thing that started in 2013. This is actually a picture of the first Robot in 3 Days robot. A nice, simple, human-loaded Frisbee robot that could store 4 Frisbees and shoot them with these 2 massive, wheelchair tires. It was pretty impressive. I think the caveat here is it's very often. None of the solutions at RA3D are something that you necessarily should build one-to-one, but they're a good kind of indicator of what the solution space looks like, right? They're a good indicator of what things generally work, what things aren't working, what are some things you need to avoid or look into further. RA3D is a great place for inspiration there. The one caveat that you can basically full-on cook with are endgame solutions with RA3D. Usually there's like 1, 2, or 3 different endgame solutions that Robot in 3 Days validates with the full robot that's just like, well, that's gonna work, right? And you can probably take that one for your robot, right? I think about climbers this year. There were a couple of climber concepts out of RA3D that teams all the way through champs were running effectively. Like 2056 and Orbit, both Einstein teams this year ran twist curl climbers that were very similar to like 2 different RA3D teams this year, just with slight refinement over the next 4 months, right? So these concepts that come out in RA3D, some of them can be really effective at pulling basically one-for-one into your robot and then starting to iterate from there. Okay, and then Open Alliance, videos in CAD, another great resource for inspiration on how to solve problems. This is like full-blown solutions coming in CAD. There are a handful of perennially like top 100 teams in the world that are in Open Alliance, and their entire CAD is actively published to the internet. 1678 has made a lot of great use of these resources in the past. I just took a screenshot of our beta robot file structure, and I just want to highlight the end effector Rembrandt style, Rembrandt's climber, Ghost, which was another FRC team, Coral intake, Red climber, Rembrandt's end effector 2.0. I mean, like, there's a lot of just, like, we put it in our file structure. the teams that we're copying from in any given year, right? Because we're using these inspirations to accelerate us getting to the final answer. So another great resource to lean on. Okay, so wrapping up, all of these methods are important pieces, in my view, to having a effective answer to how do we solve the FRC challenge in a given year. I highlight this because this is our 2024 beta robot. I mentioned that we copied Spectrum for our Epsilon, which was our third crack at the Pi. Our beta robot was terrible, and I think a big part of our beta robot was terrible because we built it without a really strong understanding of some of the elements of prototyping, hand sketching. We just kind of went for it and we assumed the notes would behave one way, but we didn't have prototyping to validate. And actually we didn't have prototyping to validate that the climb would work. We just kind of sent it on that too. And a lot of these things were just absolute failures. So that robot just went into the the dumpster of history, and we started from scratch again. And so what we're trying to do on Citrus this coming season is get more formalized about using these 7 elements of answering the hows and getting better at each of these pieces so that we can avoid some of the mistakes that we made in the past with some of our robot builds and get a little bit better year over year. So with that, there is a QR code that you can give feedback on this weekend. It'd be great. I've been requested by our fall workshop planning committee to have asked people to fill this thing out. If you would not mind doing me a favor and filling this out if you can. And while people are working on that, I would love to take some questions. We have about 10 minutes for questions. So yeah, let's go around.
How long does prototyping usually take? And also, if you don't have like a CNC machine, like how long like prototype?
Yeah. Okay, so 2 questions there. How long does prototyping, I'm gonna repeat it just for the microphone. How long does prototyping usually take? And how would you approach prototyping if you don't have CNC machines? I'm assuming like a router or a CNC mill, right? So a couple of things I would do. I would so for prototyping, it really depends on the system actually. Some prototypes wrap up within a week. Some prototypes, like launcher prototypes for the notes in 2024, we were cranking out iterations of the prototype for like 3 or 4 weeks post kickoff. And it really depends on just the level of refinement you need in a given system to be effective. So I'll start with that. And then on the how to prototype effectively, actually I think that example I gave of the different, like I think the 5026 system, that hopefully you have 3D printers or access to someone who can 3D print, because some of those blocks are really easy to 3D print, and then you can do all the adjustments manually without needing any CNC equipment to do the prototyping work. And then once you get to geometry you like, you can CAD it and then send it off to FabWorks, and you don't actually have to keep any of those resources in-house. It's way easier now to make stuff than it was a decade ago, and you can use those resources to your advantage, and you don't have to have all this fancy equipment in-house to really build effective robots if you use your resources wisely. Yeah. Yes?
So you're talking about like you have an extra week basically of just your decision-making process and kind of finalizing an architecture for the robot. Does that kind of dig into time for CAD to come up with those architectures and then later on like push season out, I guess, into?
Yeah, that's a great question. Yeah, does it eat into the rest of our season by doing it this way? I'm actually hoping the answer is no, and I'll make a pitch for why I think the answer might be no. I think it won't take up any additional time because we're going to save a half day on the front end by cutting our discussion short, and we'll add that on towards the end. But the other thing I think it's going to do is we're not going to avoid we would have prototyped regardless. We would have started Crayola CADing regardless. We would have done mock cycles regardless. We would have built the alpha regardless. I actually think a lot of the things that we're doing before we make that final decision a week later are things we would have done anyway. And so I think the theory is that let's just flip-flop the order for some of these things and get a lot more insights before we make those key decisions in order to be just a little bit more informed and maybe avoid some pitfalls that we would have jumped into with both feet if we had been trying to lock in that decision a week earlier.
Would kind of compromising between those and having to be like a Saturday, Wednesday thing, or instead of like a Saturday, Saturday thing, be like more like, I don't know if we do that if we'll have time, but I feel like we can also fit proto into like the 9 hours between like kickoff ending on Saturday and then having like a next build meeting Wednesday.
Yeah, the reason why we picked Saturday is I think that's generally when we can get an alpha running and when we can hit some of these other milestones. So I worry with 3 days we just won't have enough time to get the insights that we want to answer. And again, the other thing is we're not holding off the entire decision-making process. I think maybe I skipped over this or just answered it briefly, but the idea is that we're going to answer a bunch of the obvious questions right away. It's really only, if we're doing our job, it's probably 3, maybe 4 elements that we don't have a firm answer for yet, and those are the things that we're going to put off and get more data on. But for the most part, it's full cook. You know what I mean? Full cook on CAD, full cook on Crayola layouts, and maybe even starting to detail out some systems that we know we're going to have. Like if we knew we were going to have a Coral intake, let's just start hammering out a couple of versions of the Coral intake. We're not going to wait until we finalize the scope the following Saturday to flesh out some of these things. That's the theory, at least. Yeah.
So,
Yeah. Oh, sorry. Yeah. Let's hop around a little bit. Yeah. Go for it.
I'm just wondering how your timeline for like actual bot CAD interacts with these other timelines of like prototyping and AlphaBot, because wouldn't it be like constantly informing actual CAD if you start them around like similar times, and then wouldn't that lead to like more changes later?
Yeah, that's a great question. To be in our experience, I think to be effective in the FRC design space, it's totally iterative. You're going to learn more as you build more prototypes. Where I think teams find more success is when they can as best as possible, separate the unknowns from the knowns as they design a robot. So for example, maybe 3 or 4 days into build season, we're going to know justifiably like what drive base we can lock down, maybe even where we think the elevator is going to be, or where we think what side of the robot we think the intake's going to be, and where the climber is going to be. And we might not know exactly what they look like, but we know they're roughly going to take up this space. And Crayola CAD is great for that, by the way. Crayola CAD helps you lay out the overall robot and where things might be. And so just a great example from this year is we had our elevator fully detailed out by like day 10 maybe, right? But our end effector was a total unknown, and we pivoted between like 3 more end effectors for the next 2 months, right? But those were independent of the elevator. Like the elevator could be the elevator and exist in this one space and hold open another chunk of the robot for whatever magical end effector was going to come up across prototyping. And so, but it's a really hard, it's not an easy thing to do, but I think trying to split up things that you can know and assume versus things you don't know yet, and having those interfaces separate, or having clear interface points between those different systems allows you to lock some things down and move them to fabrication and forget about it and be like, all right, that part's already done, it's cooking, the robot's not waiting on me, but other stuff we need to wait on.
And this ties into like splitting things into like smaller chunks that you can put together.
Yeah, and setting up good interface points on your robot. I think inherently we have good interfaces because almost all of our robots have a bunch of half-inch holes everywhere. Like that's a great interface point because you have no idea what's going to mount to the half-inch hole, but I'm going to put a half-inch hole pattern and hope that I have something that can gusset on there later, right? It's why our drive bases have holes everywhere. Like you may not, explicitly state it, but they are a bunch of interface points all around your robot that you can mount basically anything to, which is exciting. In the back and then in the front. Yes.
Is there any sort of pre-training you do for like the decision-making crayon CAD for people that aren't as familiar with design?
Yeah, so how do we train on like design of like sketching and stuff like that, of like how to come up with robot ideas? Is that kind of the question? Yeah. So we do, for our new team members, we run a mock kickoff weekend in December where we go through both the answering the what questions and practicing the hows a little bit, so you get some hands-on experience with sketching. And I think the reality is going through a year of robots is probably the best trainer you can get as far as what robots look like. But I actually, thinking about now, there's only so much time we have to do all this training, but maybe like an extra day or 2 of hand sketch training would be valuable for our team. It's just hard to find the time with everything else. But yeah, go through a mock kickoff with your team. You'll learn a lot of things. I highly recommend doing a mock kickoff if that's not already part of your flow. Yeah, Brett.
With so many prototypes, how can you ensure that they all will flow cohesively in one robot? Accidentally, oh no, I accidentally went 2 inches off and I don't fit with that other robot part.
Yep. That is a great question. So how do you fit, how do you ensure that these different things that are being worked on in parallel are fitting together? Actually, so this is another plug for the Crayon CAD step of this, because the Crayon CAD is a tool where maybe your lead designer or a couple of veteran designers can roughly mock out the space take-ups of the various mechanisms, and give some guidance to the prototyping teams as far as, hey, can you try to make this work within this volume, right? The other element there is sometimes it comes down to how you package like the deploys and all that sort of stuff. So like, do you use a flip down intake or a 4-bar intake? And that's where Crayola CAD is actually more helpful than the prototyping. The prototyping, I would encourage, the prototyping probably shouldn't be actuated intakes. It should probably be static intakes that, like, for example, that alpha that you saw for 22. Put it up on here really quick. This intake, although you see pneumatic cylinders on it, those didn't work. So this thing just stayed out. You know what I mean? So it was very much, it could have just been like cardboard and zip ties on there. You really want to lean into the Crayola CAD element, and then starting the detail CAD to figure out the space take-ups. And then there is a back and forth with the prototyping team. The other thing I would say in effective prototyping, it's really hard to see. I'm sorry, this is like a very small picture. I wonder if I can zoom and enhance here. No, that's not going to work. But you see the tape measure in all these pictures here for the prototyping. If this isn't, like, this is another key part of communicating prototypes effectively, is taking a plethora of tape measure pictures, because your designers can reference that material afterwards and make sure that the mock-ups, or in some cases the full detailed designs that they're putting together, are actually matching what you found worked in person. Does that help answer the question? Yeah, but it is it's a tough challenge. And actually, this is another pitch for just making robots that are just way simpler, because the less stuff you have to fit, the easier it's going to be to make sure your prototypes can be built one-to-one in the robot. So it's another pitch for simple robots. Yeah, go for it.
Usually when we've done prototyping, we've just like CNC'd out of like random wood, just very cheap and dimensionally accurate. Do you guys usually CNC it, or?
For us, it's a total mix. Some of it is we try to do like the pre-built blocks and tube and just kind of fit thing to length. Sometimes it is CNC routed polycarb or wood. Sometimes it's laser cut wood or plastic. Yeah, it really just depends on that. Sometimes it's just hand drills and punching holes in wood. You know what I mean? Or like sometimes you can buy this like pre-drilled sheet, and then you can just decide which holes you want to punch out to bearing holes or shaft holes and putting those through. And a lot of drills or motors on test boards. It's a whole kind of mix. It's one of the things, I think I alluded to it in the presentation, but it's one of the areas I want to improve on our team is the standard tools that we have in place to help all teams, all of our prototyping groups be faster and more effective, because I don't feel like we're very fast right now.
And then how many students do you usually have working on prototyping? Like how many separate teams?
How many students and separate teams? We generally have 6 prototype groups and about 8 to 10 per group. So yeah, about 60. Yeah. Yes, in the back.
Do you have people in charge of making sure of like going between different prototyping groups?
We generally don't assign our design lead to any prototyping group so that they can bounce between all of them. So the design lead is the one who's responsible for making sure all the CAD's going to come together. They're assigning subsystems for different students to work on. And so they generally don't get assigned a specific prototyping group, and instead they're making sure that all the prototyping groups are developing in a way that is more likely to generate a cohesive robot. Yeah. Maybe one more in the back. We're getting past time. Yeah.
Can you elaborate on how you set a team culture to ensure that no one is attached to the mechanism that they make?
Yeah. Yes. This is something that, believe it or not, this is a tool that is going to be helpful for you for your entire career as an engineer, as a collaborator. The idea that we want to encourage more ideas brought to the table, and we want to discourage ideas being assigned directly to people. And so what we try to do is, as best as we can, not refer to ideas as, so-and-so's prototype or so-and-so's sketch. Instead, it's the prototype of this version of the climber that's going to grab the bar and pull it down, or it's the sketch of the intake that uses spike wheels to funnel the game piece, right? It's the idea that you're trying to separate you don't want to assign ideas to people by name and say that's Jerry's idea, right? Because what that's going to do is it's going to set a value proposition on Jerry on whether or not that idea is successful, and it's going to result in more disappointment when things don't go that designer's way. Yeah.
Can I just add to that?
Yeah, sure.
'Cause we have the same idea in professional languages too. You can detach judgment from idea creation. There's a phase of idea creation.
Yes.
And that's the goal, is to create ideas. And then you have a separate judgment phase where you evaluate ideas. And that creates a break from being, oh, my idea is getting trashed. Like, you get all the ideas out, your value for creating an idea.
Yeah, absolutely. So we have 20 groups that are sketching out how ideas, and we're collating all those sketches and listening and understanding. This whiteboard is the result of probably an hour and a half of presenting sketches. And we're doing exactly what you said, which is we're allowing space, we're building space for every student on the team that has an idea to get it down on paper and present it to the rest of the team without it getting picked apart. It's just seeking to understand and collecting all that information onto the whiteboard. After we've done that, then it's down select. Then it's talk about merits of one option over the other, and we start to down select and get down to the point of we're definitely going to go with this idea, or we want to prototype these 3 ideas that seem like leading contenders. Okay, it is 6:18. I'm keeping people late. I will hang around here and answer any additional follow-up questions that people have. Thank you very much, guys. Appreciate it, and have a good evening.